For almost 5 decades, the UH-60 Blackhawk has been a symbol of helicopter utility. Medevac flights, special operations insertions, and frontline resupply missions. It's the aircraft commanders ask for when people or critical gear need to move into, or out of, dangerous places. Today, that familiar rotorcraft is being nudged into a very different future. The U-Hawk is a UH-60L stripped of its cockpit, fitted with clamshell cargo doors, and handed over to autonomous flight software. The result is not an optionally manned demonstrator, but a true unmanned rotorcraft. And its existence signals a major shift in how military aviation might operate. A Blackhawk without pilots. What does that really mean? The modification itself sounds deceptively simple. Engineers removed the cockpit. No seats, no cyclic, no controls, no pedals, no flight instruments. In its place sits a pair of clamshell cargo doors and the brain of the aircraft, Sikorsky's Matrix autonomy system. The UH-60's original identity revolved around the skill and courage of the pilots inside it. The U-Hawk's identity revolves around software and sensors that think and act without human hands on controls. Matrix is not just a fancy autopilot. It is an autonomy framework that interprets the environment, navigates terrain, avoids obstacles, lands in unprepared zones, and reroutes on the fly if the mission changes. It has been tested through Defense Advanced Research Projects Agency ALIAS program, proving it can fly missions a human crew would normally be required for. Where older research platforms still kept human controls as backup, the U-Hawk takes the leap none of those dared to take, removing human pilots entirely. The result is not a pilot-assisted helicopter, it is a pilot-replaced one. Why removing people changes everything. The moment you eliminate the pilot, you eliminate the need to protect them. No cockpit means no armor plating, no ejection survivability features, no crew displays, no seats, and no human fatigue limitations. Every pound saved can become fuel, sensors, weapons, or cargo. In aviation, weight is life. In war, it is advantage. Suddenly, the aircraft can carry dramatically more, and it can do so in places no sane pilot would ever agree to fly into. The strategic value becomes crystal clear. A machine can be sent where death hovers in the air. A machine feels no fear, no hesitation, and no loss if it never comes home. That capability alone reshapes how commanders might operate in future conflicts. A U-Hawk can push into zones where anti-air missiles roam, where jammers pulse through the spectrum, or where swarms of hostile unmanned aircraft buzz like locusts. If it gets destroyed, the loss is steel, not blood. A logistics monster in the sky? The U-Hawk's new internal volume is a luxury no UH-60 crew chief ever enjoyed. With no seats or crew systems, the aircraft gains tremendous capacity. The unmanned converted airframe can haul roughly triple the internal cargo of a typical manned Blackhawk in many configurations. Ammunition pallets, field generators, autonomous ground vehicles, water, fuel bladders, rations, medical kits, whatever the battlefield demands, can load and unload rapidly through the clamshell doors. This is not simply a transport helicopter. It becomes a flying lifeline for distributed forces. Think of future conflicts in the Pacific. Small marine units on island chains, constantly relocating, always hungry for fuel, drones, and munitions. A U-Hawk can depart on an autonomous route, land at a primitive clearing, unload supplies, and depart again, all without exposing pilots to hostile skies. It may fly 14 hours on station, self-deploy thousands of miles, and cycle missions without a rest break, because robots never tire and never need coffee before takeoff. A multi-mission platform. While logistics is a core purpose, the U-Hawk can extend its claws far beyond transport. The aircraft can serve as a carrier for launched effects, a military term for small drones and airborne tools that can be released like arrows from a technological quiver. These effects may conduct reconnaissance over a ridge, spoof enemy radars, jam communications networks, drop loitering munitions on enemy armor, or act as tiny robotic scouts that feed targeting data back to command. Suddenly, the U-Hawk is not just delivering cargo, it is shaping the battlefield from above. It can hover quietly in holding patterns while deploying intelligence drones. It can support special operations by dropping sensor pods or laser designating targets. In a hostile airspace, it can release electronic warfare packages to blind enemy radars, long enough for a manned aircraft or ground unit to slip through. This is not a single-purpose tool. It is a platform for battlefield imagination. Future medevac without human pilots. For soldiers, one of the most emotionally significant promises of unmanned rotorcraft lies in battlefield casualty care. In Iraq and Afghanistan, helicopters often arrived within an hour to save lives, because America controlled the skies. But future wars may not grant that luxury. Air defenses and drones make medevac flights more lethal than they have been since Vietnam. Imagine instead a robotic helicopter rising into contested airspace. It flies autonomously to a designated landing zone while troops secure a small perimeter. The aircraft touches down without a pilot inside. A robotic ground vehicle rolls out of its bay and crawls to the wounded through shell-torn terrain. It loads the injured and brings them back to the U-Hawk, which then lifts off and takes them to a safe surgical location. No flight crew risks their life. No medevac pilot faces a missile while saving someone else's son or daughter. In this scenario, technology becomes the protector rather than the threat. Civilian and emergency uses beyond war. Although born from combat needs, the logic behind the U-Hawk extends smoothly into civilian crisis operations. Remote wildfire zones, hurricane-cut regions, and high-altitude rescue environments are all deadly for human pilots. An autonomous helicopter with huge lift could insert firefighters, deploy emergency food and water, or ferry out stranded civilians. Offshore oil platforms could be serviced without risking crews over open ocean. Search and rescue missions in mountains or storms could unfold without fear of pilot loss. What starts as a military tool often becomes a civil asset. The helicopter era may be reborn, not with pilot helmets and flight suits, but with autonomy cores and sensor packages. What comes after U-Hawk? A fleet of autonomous warbirds. The U-Hawk may be the first test case, but it is not the end. If proven effective, other aircraft stand in line to evolve. An Apache helicopter freed from human pilots becomes a stealthy, persistent hunter-killer, waiting patiently over valleys or coastlines, striking armor or drones with no concern for threats below. A CH-53K or similar heavy-lift platform could carry vast amounts of supplies, even artillery modules, missiles, or palletized weapons like the Air Force's Rapid Dragon system. The aviation world is quietly marching towards something radical. Aircraft designed around software rather than the human body. In the long term, clean sheet rotorcraft could arrive without windows, without armor shielding, without egress systems. Just aerodynamic shells housing power, sensors, autonomy cores, and mission modules. They might be smaller, faster, stealthier, or optimized for aircraft carrier decks or submarine bays. The idea of cockpit windows may feel as quaint someday as manual propellers feel today. New power brings new vulnerabilities. For all its promise, autonomous aviation suffers from new fragilities. A human pilot can improvise in chaos. A machine cannot always interpret the unpredictable. GPS interference, cyber attacks, jamming, spoofed signals, and software faults all pose serious risks. The U-Hawk may fly without a heartbeat, but it still depends on code, communication links, and algorithms. Losing those can be as fatal as losing lift or engine power. Training will shift, not toward helicopter stick and rudder mastery, but toward systems monitoring, mission oversight, and fault response protocols. Armies will need coders, robotics specialists, EW experts, and cyber defenders the way they once needed legions of pilots. The battlefield advantage comes with a price: complexity, a turning point in military aviation. The U-Hawk is not a replacement for pilots, not yet. It is a bridge between eras, a signal flare fired into the future saying, aviation is changing, autonomy is real, and the machines are stepping forward. Humans flew Blackhawks into danger for decades. Now Blackhawks may continue flying, but robots will take the first steps into the fire. Whether this change spreads depends not just on technology, but on trust, doctrine, ethics, and necessity. But the door has opened. The helicopter that once symbolized human courage in the sky now symbolizes something equally powerful: human ingenuity reshaping the sky itself. The Blackhawk isn't fading, it's transforming, and the U-Hawk is its next chapter, one where the future isn't flown by hands but by code. If you enjoyed diving into this future meets history moment, make sure to hit like, subscribe, and tap the notification bell so you never miss the next video. Thanks for watching, stay curious, stay sharp, and I'll see you in the next one.